Hi everyone, I'm Tushar Gowda. I have Borang Liu with me here. We are attempting to support micro BFD hardware offload as part of SONiC Hackathon. So agenda for this presentation is to provide use case, our proposed solution, provide a quick system overview, a sample configuration. We'll jump into demo so that we spend some time there and have some time for Q&A as well. So use case is straightforward. We want to have faster member link failure detection time. LACP provides 1 second granularity today, but we want to go further to milliseconds range. We want to be able to predict failure times correctly and accurately every time. And we also want to monitor the data path aliveness, not just physical link status, and do all of this by avoiding the CPU load. The solution that we are proposing is to use micro BFD. It provides link monitoring times in milliseconds. We can offload the hardware session, BFD session to hardware. Because now we are monitoring through the hardware, we have predictable detection times. We can support high scale based on the capability of the ASIC. And since we are offloading the BFD session, there is little impact to the CPU. So this provides a system overview. Most of the components here are well aware. Everybody is probably well aware of it, but these are all SONiC components. We have had to make changes extensively in Team Manager and a little bit in BFD org. The lines here are showing the control flow. The back lines are showing the LAC config flow. The red lines are showing the BFD config flow, and the dotted blue lines are showing the state update. So the Team Manager is doing a few things extra, where it is listening to the BFD configuration data from the config DB. It is also configuring the BFD in the app DB for the BFD orchestrator to consume it and to send it down to the SIN SDK. Apart from that, it is also listening to the BFD state updates from the state DB. So whenever the SDK or the SI returns the BFD session status, it gets percolated to Team Manager. That is required so that it can go and update the TeamD and the Linux about the link status. And the changes here are not too much, but this is the overview of the system that we have. And this is the sample configuration that we have to use. We need to use the IP addresses for the peer and the local, because BFD requires us to have an IP address, and the BFD session timers as well. So right now it's 1000. We can configure the value depending on the capability of the ASIC. So with that, we'll just quickly go over to the demo, and Borang will take you through the demo.
Yeah, thank you, Tushar. So let's go to the live demo here. So we have a setup with the 2 rods connected back to back. Left one is rod 2. The right one is rod 1. We have a port channel with 3 members. So for the rod 2, you can see we have a port channel here, and there's 3 members. And we'll have a we have 3 BFD sessions, each BFD session for 1 member. So you can see here the state is up, and we can see so 3 BFD session here, and the state is up. And currently, all the 3 members are selected. So we'll try to remove 1 BFD session from the R2 to make another set see the state down, and we will see the one of the link member will be deselected. So let's delete 1 session. You see here 1 session is deleted. And let's see other side. So we can see that one BFD session is done. Let's show the port channel again. So see this member got deselected because of the BFD session state is done. And let's add the session back. Yeah, we can see that the BFD session for is not all can add back and the state is up. So we check here. So we can see that the BFD state changing. And let's show the port channel again. So we can see that the Ethernet for that member got selected again. Yeah, that's lab time.
Thanks, Parang. So we can now take questions from the audience.